Hello there guys, welcome back to another epic inexorable maths video. In this video, we're looking at the integral test once again. This is, I believe, the fourth video on integral tests, and that's obviously part of the greater topic of convergence tests. And in this video, we have something that maybe looks quite complicated, but actually guys, don't worry, it's not really that bad. We want to determine whether that sum there, I won't read, well, I will read it out just in case anyone can't read my handwriting. So the sum from n equals 0 to infinity of 3n squared plus 4n plus 5 divided by 3n cubed plus 6n squared plus 15n plus 1. And we want to determine whether that converges or diverges. And also, to save us a little bit of time, I've said that we are given that the function is monotone decreasing for all values of n in the natural numbers. So basically, the series is decreasing. Okay, so every time that you increase what n is, the resulting fraction is smaller every single time. We don't need to prove that, because if you did have to prove that, you'd have to use differentiation and it would be a real nightmare. You can also look at it on an intuitive level, and you can see that the denominator is a cubic, the quadratic is a quadratic, the numerator is a quadratic, so the cubic grows faster than the quadratic, so that's also another reason. But I've just written, we're given that in the question, so we don't have to think too much about it. So we want to do the integral test. Let's just get going with it, and hopefully this video should be a little bit shorter than the previous two, because I know they've been quite long, and I like keeping these videos nice and short for you guys just because, you know, short and sweet tends to be better. But I want to make sure that we go through this really thoroughly. I don't want to just gloss over stuff because it's a hard topic. Okay, how do we do this? Well, let's draw the function. Now, the thing is, guys, is because it's decreasing, it's just monotone decreasing, that means it's decreasing and it never increases again. Because of this, we don't really care exactly what it looks like. I'm not going to be trying to determine what it looks like by doing differentiation or plugging values in. We just know that it's decreasing. The only value that I'm going to talk about is when n is 0, we know that we have the number 5, because every single term here is 0, except we have 5 divided by 1. So here we know on the kind of y-axis, I guess, we'll have 5, and I'll draw it a bit higher up. This is 5 here. Other than that, it is just decreasing, so it just looks like this, roughly. Cool. Lovely stuff. Okay, now, do we think that this is going to converge or diverge? Well, this is an example that I was talking about 1 or 2 videos ago when I said sometimes it's really difficult to know. There is no real reason. I wouldn't blame you if you said that you think it converges, or if you think that it diverges, or if you're not entirely sure. That's absolutely fine. I don't think it's like, oh, it's really obvious that it converges or diverges or whatever. So let's just take a step back for a second. One way to do this, if you're really not sure and you don't want to spend too much time guessing wrong, is we can just do the integral, and then we can determine if the integral converges or diverges. That will help us determine whether we think the sum diverges or converges. So let's just do the integral. So I'm going to write down the integral, and it's not really obvious where we should start from, but let's just start from 0 for now. The integral from 0 to infinity of 3x squared plus 4x plus 5 divided by 3x cubed plus 6x squared plus 15x plus 1 dx. Now, you might think this integral looks really hard, and in some ways it can be, but there's actually one thing that we can notice. Do you see that the numerator is 3 times the derivative of the denominator? Okay, so if you differentiate the denominator, I'm going to write this down actually because it's useful. The denominator would differentiate to 9x squared plus 12x plus 15. And do you see that that is 3 times 3x squared plus 4x plus 5, and this is the numerator. So because the derivative of the denominator is a multiple of the numerator, or the numerator is a multiple of the derivative of the denominator, whatever way around you want to do it, we can use the reverse chain rule, and actually this is going to be a very easy integral. So let's work out the integral. So this is the limit as t approaches infinity of the integral from 0 to t. Remember, it's an improper integral, so that's why we have to do the t, of the same thing, 3x squared plus 4x plus 5 divided by 3x cubed plus 6x squared plus 15x plus 1. Okay, this would be the limit as t approaches infinity of, well, what will it be? What's this going to integrate to? Well, guys, if you have that, and I'm going to write this down as well. I'm going to write this down as well. Okay, remember that the integral of, let's say, the derivative of f of x divided by f of x with respect to x is the natural log of f of x plus c. Okay, this is obviously the indefinite version of it. We don't need the plus c here because we've got limits, but remember that that is true, okay? Because if you differentiate the natural log of something, you do get the derivative of that thing divided by that thing. So what we have here is actually just going to be the natural log of the absolute value of the denominator. So it's ln of, and I should also put square brackets around this, ln of, and I might actually have to rub this out, but hopefully you guys are already pretty happy with this natural log stuff. Should be quite basic by now. We're going to have, yeah, the natural log of 3x cubed plus 6x squared plus 15x plus 1. And we have to be very careful because also, and obviously we have the limit 0 to t. Remember, guys, it's not exactly that the derivative of the denominator is the numerator. The derivative of the denominator ends up being 3 times the numerator. So when we do that, if we were to differentiate this, what I'm saying is we would actually get 3 times what we should get here. So the derivative of this is 3 times this. So we need to divide it by 3. So I'm actually going to make some space. I should have left more space here, but actually this is going to be 1/3 times the natural log of all of that, okay? The 1/3 is because, again, if you differentiate the natural log of all of this stuff, you end up getting 3 times this. So you need to divide by 3. Okay, cool. Other than that, we can just plug in. So we have the limit as t approaches infinity of 1/3 the natural log, plugging t in, of 3t cubed plus 6t squared plus 15t plus 1 minus 1/3 the natural log of just plugging 0 in. So 0, 0, 0, 0, 0, 0, and then we have a 1 here. Okay, cool. And this, guys, hopefully you can see, this is going to be infinity, okay? This is divergent because as t approaches infinity, this is the natural log of infinity, which is just infinity. And it doesn't matter that we're taking away the natural log of 1. I mean, the natural log of 1 is just 0 anyway, but this is indeed infinity, which means that the integral diverges. What does that mean with respect to the sum? Well, if the integral diverges, then we can't use it to show that the sum converges. We can show that it's less than the integral, but it's less than infinity. That's useless. It could be any number. It could still converge, but it could also diverge. If it's less than, I should say less than or equal to infinity, it could still be infinity. If the area beneath this graph is infinity and we draw it below that, it doesn't actually mean that it's infinity. Like, it doesn't. There's loads of infinite things that you could draw underneath this, right? So that doesn't help. So the only way round that we can do this, if the integral diverges, is if we can show that the sum is always bigger than the integral, we can show that the sum diverges. So the only way of doing this is by showing the sum diverges, okay? Again, you could have done this the other way around where you just guess first and then end up coming to a conclusion, but that's fine. Okay, so let's draw in some random terms here. So well, a few random points, 1, 2, 3, 4, 5, etc. And guys, I am not going to try and calculate what all of these terms are because obviously it's a very, very complicated sum. What I do know though is when n is 0, we have the number 5. And remember, I want to draw these where the rectangles are bigger than the function down here. So I'm going to draw the rectangles like this. Okay, hopefully this makes sense. I haven't spaced them out very well, have I? But they should all have the same width, a width of 1. And so on and so forth forever, right? Hopefully that makes sense. And this here is the sum from n equals 0 to infinity. But guys, we can see that this is bigger than the integral. So what I'm basically saying is that this integral here is less than or equal to the sum. I'm just going to shorthand this one, guys. I'm going to go n equals 0 to infinity. I'm just going to call this one f of n, but f of n is just going to be this thing here, just so I don't have to write out that whole fraction, okay? The sum that we're talking about in the question clearly is bigger than this integral, but we've just worked out that this integral is infinity. So it's bigger than or equal to infinity. And so does it diverge or converge? It diverges, okay? So this thing here, where shall I draw it? It diverges. It's equal to infinity. Hopefully that makes sense. As always, guys, if you have any questions about this particular topic, then please just let me know in the comments below. But yeah, this one's kind of a fun question. Looks really complicated, but actually not really too bad at all, hopefully. And yeah, thank you guys so much for watching as always. I highly appreciate it, and I'll see you in the next video. Cheers.